Hey folks, so today we're going to be going over the Ponables.kr, the very first challenge in the Toddler's Bottle series, which indicates clearly that it's a much easier challenge. So we're going to go over the FD challenge, and this is going to be a bit of a walkthrough, which means I already know kind of the direction that we should go here. So here's the FD challenge, and as I get closer and closer, I'll start trying to do these live so you can actually see kind of how I think when I'm trying to solve these challenges. So the first thing we got to do is we always have to read these challenges. This is actually very clear. There are hints sprinkled all throughout all types of capture the flag and wargaming challenges. For instance, the name of this challenge is called FD. FD, that kind of sounds like a file descriptor, so maybe that's a hint of some sort. And the text even says, "Mommy, what is a file descriptor in Linux?" So this would actually be a good thing if you actually don't know anything about file descriptors in Linux. Here's a hint right off the bat that you should go and learn and read about file descriptors on Linux. This is something that's critical to competing successfully in capture the flags and other types of war games. It's all about knowledge. So if you don't have the knowledge, if you don't understand what file descriptors are, or you don't know how file descriptors work in Linux, you're never going to be able to solve this challenge. And here, because this is the very first one, it says, hey, try to play the war game yourself. And this is actually a huge key, is really, if you're watching this video without attempting this challenge first, you should really not do that. You should be approaching these challenges, banging your head against the wall, trying to solve these things. And only then, when you break through and solve it, then you can go back, watch this, see how I did it, see how I thought about approaching this. And that maybe can give you some pointers or some tips, and maybe you can go, oh, that's such a cool thing. I haven't thought about doing it that way. So here's this link. So try to play the war game yourself, but if you're an absolute beginner, follow this tutorial link. And so here's a link to a YouTube video, but we won't get started there. So the first thing we got to do, we need to SSH. So it gives us a command. It's telling us to SSH as the FD user at the server ponable.kr, and the -P option here in the SSH means on port 2222. So this means rather than the default SSH port of, I believe, 22 off the top of my head, we actually want to SSH to a different port, and it's telling us the password to use. The password to use is guest. So what we're going to do is we're going to copy this lovely command. Oh, and you can see I've already done it here, so let's reset this. So I'm here inside my Ubuntu and cat etc issue. So you can see I'm inside a VM running Ubuntu 16.04.3, which is running on my local machine in VMware. I pretty much always work out of this, and as you can see here, I actually got rid of all of the GUI elements. So I pretty much always, when I am running a virtual machine, like a Linux virtual machine, I like to run the server edition, so I can just, here, I'll get out of this. So I can SSH into it, and then I usually like to work out of a screen and environment. So here I have a nice screen environment, so now I can start working on this challenge. So I can copy and paste this. Actually, very much dislike to have the arguments afterwards, but everything will still work. So we'll SSH. It may take a little bit, even though I was already there. So we wait. And so depending on the challenge, try to play the war game yourself. Could not resolve host name. That's not good. DNS this offline, or am I offline? So we can do curl google.com. Don't cut all of this. There we go. All right, guest. We can see that it's being very slow. Finally, we are on. And we notice that it doesn't tell us anything, right? It just drops us directly into this user, this FD user. So if we run the ID command, we'll be able to see that we're running as ID FD, and as the FD user on this system, or group FD, and we have the groups FD. And so the directory we're out of should be /home/fd, but of course you can completely change that in a Linux machine, so there's no guarantee. But when we ls-la, so we see we're in /home/fd. So when we look here, what we're looking at and we're trying to see, okay, what's the goal here? And that's actually a very important part of CTFs and war games. What is my goal? So if we go back here, we can see that it's asking us for some kind of flag. So we need to find a flag. Okay, hey look, there's a file called flags. Let's just cat out that flag and then it's game over and we won, right? So when the massive latency here picks up, we should be able to see that this, well actually I can preview this. So we know we are user FD. We can see that the flag file is, so here we got cat flag permission denied. So why did we get permission denied? Well, when we look back at the permissions here in the flag user, we can see that the flag file is owned by fd_pwn, which is not our user, and the group is root. And the permissions on this file specifically, so the Linux permissions, you have read, write, and execute for owner, group, and other. So that's three tuples there, so you can see that the fd_pwn user who owns this flag file is readable. That user can read this file. The group of root can also read this file, but everyone else, so we are neither of those two people. We're not the owner of this file. We're not in the same group as this file, so we're in the other category. So we have 0 permissions on this file. So by ourselves, we cannot read this flag file. So how does this work? How are we supposed to find the flag then? Well, we can see that there is an FD file here, and if we run file on that, it should tell us something interesting about this file. But we can jump ahead a little bit and say, okay, yes, this is an ELF 32-bit executable, which is awesome. That's what we want. And so we look and we say, okay, can we execute this file? Well, who owns this file? The owner is fd_pwn and the user is fd. So what this does, so when we look at these permissions, we can see, we first see read blank s. So we'll go back to the s in a second for fd_pwn, but we can say read and execute for fd. This means only the fd user, only us, we're the only, this group can execute this file. And also the fd_pwn, this means that it's that the fd_pwn user can read it and execute it, but also that S is a special bit that means it's set UID, which means when this fd binary executes, it's rather than, so when I run, let's say ls, this ls command is running and executing with the permissions of the fd user. But this fd binary, because of this set UID bit in Linux, it's running with the permissions of fd_pwn, PWN. So that means if we can trick this fd executable into reading this file, we'll be able to read the flag file, which is our ultimate goal here. So this is awesome. So this gives us a direction to go. We want to break the fd binary. And since this server is going to be slow, I've actually already, oh, I did not. Okay. So I'm going to add a little pause, add marker. All right. What I'm going to do is copy these things down. So what I want to do is I want to analyze this binary and the C file offline. So I'm going to use SCP, which is a secure copy, which uses SSH to copy a file from a remote machine to our local machine. So I'm going to FCP, it's fd@pwnable.kr, And the other important thing is the port. So we know we're on port 2222. It's only from experience earlier today that SCP uses the $P flag for the port, whereas SSH uses $p. I'd never remember that otherwise. And what file do we want to get? We want to get the FD file, and we want to copy it here. So this is going to attempt to SSH into that server as that user to copy the FD file locally. And we can see we will wait for it to give us the result. And now I'm going to have to go and copy let's do it by IP address, since DNS is having weird issues. We'll blame it on other people, not on me, but okay, who knows? Password guessed. So now it'll copy that FD binary locally, and this is important so we can look at it and understand what it's doing. We also noticed the other important thing is that there's this fd.c, a C code, so this is good, and this makes sense, right? So the important thing is, as you're doing these challenges, to always go back and verify your assumptions, right? What are our assumptions here? Well, this is in the toddler's battle category, and it's the very first challenge, and it's worth 1 point. Now, we haven't looked at anything else, so we don't necessarily know the point structure yet, but we should think that it's an easier challenge, and if you have C code, you're gonna have a much easier time because you don't have to necessarily reverse the binary. So we get that, let's get fd.c, and we can start looking at these things locally. There we go, guessed. Great. All right, so let's cat fd.c. So we can look at this application, see it has a main function. It's not very big, so that's actually a good plus for us. We can see the first check, if argv is less than 2, pass argv1 a number. So remember, so argv is the first argument that gets passed into main. Argv tells how many arguments are in the argv vector. Argc specifies how many arguments are in the argv vector. Argv bracket 0 is usually the name of the file that gets executed. So if we were to run fd, the argc would be 1. Now what we need, so it's saying, okay, we need to pass a number. What does it do? It has an int fd for file descriptor, probably atoi, which means it takes in, and a super important thing to do, if you don't understand what something does or what some function does, always read the documentation on that function. So here, if we didn't know what atoi meant, we could say, oh, we know at least here from its signature, it's something that takes in a character pointer and returns an int. And we can actually read the description, converts the initial portion of the string pointed to by n pointer to int. And so basically it's just going to try to convert a string into the integer representation of that string value. So it's going to set that, but the important thing is here, it's going to subtract hex 1, 2, 3, 4 from that. It's then going to have a length. It's then going to say, read in from that file descriptor into buffer. So buffer here is a global buffer that's 32 characters, 32 bytes. So it's going to read 32 bytes from the file descriptor into the buffer. And then it's going to check, does that buffer equal let me win new line? If it does, so this is an important thing of strcmp will return 0 if the strings match. So that's what this not string compare is doing. Then it will say printf good job, and then cat out the flag, and then exit. And saying, hey, learn about Linux file IO. So this is actually a nice thing that the developer of this challenge has put in to help us learn and understand and try to, if we've never experienced this before or played this before, to know how to go learn more things about this. So I can run fd, and say pass argv as a number. I'll say 10, and it says, you need to learn more about file IO. And so what's the goal here? Well, the goal is to pass this check. Well, the goal is to ultimately get the flag, right? That's always our ultimate goal. So how can we do that? Well, the interesting thing is basically our input, our file descriptor input, is being passed into the read function. So if we do read, we can see that in the man page, read is a function that takes in a file descriptor, a buffer, and a count. And the description said read attempts to read up to count bytes from file descriptor FD into the buffer starting at buff. So what we need to do, so now we want it, so now the key to understanding this challenge is we can completely control this FD parameter. We can completely control what this FD parameter does. So the question is, what do we want this parameter to be, right? And it's important to remember this is one thing you want to burn into your mind when you're doing CTFs and CTF challenges, is that by default, file descriptor 0 will be standard input. And that's, so for instance, when you type in cat, it's waiting for input from standard input, and it's gonna write that to standard output. So standard input is file descriptor 0, standard output is file descriptor 1, and standard error is file descriptor 2. And these are constant in all, I believe, POSIX-based systems, but I don't know, but it's something to definitely burn into your brain. So we can see on our local machine, if we do 0x1234, so that did not work because ATOI is not using hex values. So we need to convert. So basically we want the FD variable to be 0, right? We can't pass in 0 because it's subtracting 1, 2, 3, 4 from it. So if we do, what's binary 1, 2, 3, 4? Hex 1, 2, 3, 4, convert that as 4660. So if we do FD 4660, and now, so what is it doing? Now it hung, right? That's an important thing. So what it's doing is now it's reading 32 bytes from our input. And what do we want our input to be? We want it to be let me win. Let me win, new line. And a bunch of stuff just happened. That is, okay. See if I can recover. All right, well, I killed that window. That is interesting. So let's see what happens when I do that here, because that is very interesting. So I want 4660. I want to input let me win new line. Great. And so it says, Mommy, I think I know what a file descriptor is. So we copy that and we put that. Okay, I know what happened. So we put that in here and it would tell us that yes, this is the good flag. So